So let's continue our discussion of the Pythagorean theorem, and we're going to actually say the same things multiple times with some variation. But let's backtrack a bit. So great, we get to use the Pythagorean theorem if it's a right triangle. We get to find out that if it is a right triangle, I get to use the Pythagorean theorem. However, how do we even know if it is a triangle? Or is there a way to predict if it's a different type of triangle? Well, the Pythagorean theorem, there's some inequalities, what we call them. Inequalities meaning, like with these symbols right here, that allow us to know if a triangle is acute or obtuse. We already know what makes it right is if it's equal. But we can't really test these three options until we've decided if it's a triangle or not. So we're going to need to, if we're given, let's say, for example, problem 4, if we're given 3 random numbers and we're told, hey, these could be a triangle, find out. And if it is, what type is it? Well, we have to first do this step right here, and that's find out if it is a triangle. Well, that's simple enough. It's pretty much, it looks intimidating. Here are the words. Take the 2 smaller numbers, add them up. If it's more than the other number, it's a triangle. The end. But you must use the 2 smaller sides. So for example, if we look at A, what are the 2 smaller sides? 3 and 3. So what's 3 plus 3? Well, that's 6. Great. Is 6 bigger than the other side? It's equal, but it's not bigger. So because it's not bigger, then the answer is no, this is not a triangle. So part A is not a triangle. And think about it, like let's say you pull out a ruler, right? And you actually measured 3 out. Okay, and then you measured another 3 out. And then you measured a 6 long line segment, right? So let's say this is 3, and this is 3, and this is 6 inches long. Could you actually use those 3 segments to make a triangle? Well, you could try as much as you want, right? Let's say I put the 6 down, and if I put the 3 down, it looks like this, and I put the 3 down, it looks like this. And you're like, oh, that's not a triangle because there's a gap. Well, what if I lower them down? Well, sure, right? I'm gonna what happens though is like this ends up being my 3, and this ends up being my 3. And what did I just form? A line. Okay? It's because they're equal. It has to be bigger for there to be a gap, for there to actually be an area, for there to be a triangle. So if they're equal, it doesn't work out. So you might want to make that note to yourself that, like in part A, if the 2 smaller sides add up to be equal to the other side, that forms a line. It doesn't form a triangle. Okay? Well, what about part B? The 2 smaller sides are 3 and 3. 3 plus 3 is 6. Is 6 bigger than 5? Well, yes. So it forms a triangle. Now we got to find out what type of triangle does it form. So we're going to go ahead and plug this in, right? This is 5, right? This is my longest side. That's my C. So let's call this one A. Let's call this one B. And we're going to plug it into the Pythagorean theorem. Now, the way I like to do this is I like to just leave it as a blank. I think most books do the same thing too. So just plug them in, right? That's 5 squared, blank, 3 squared plus 3 squared. 5 squared is 25. 3 squared is 9. 3 squared is 9. 9 plus 9 is 18. So I have a daughter in 3rd grade, and they're doing this exact problem right now, right? Comparing. So inequalities, which is the bigger number? Like, what do I draw? So this one's bigger, right? So 25 is bigger than 18. Well, which way is this pointing? So for part B, yes, it forms a triangle, and it actually happens to be an obtuse triangle. Because it wasn't equal. If it were equal, if this were equal, it'd be a right triangle. Part C, let's do this again. Take the 2 smaller sides, 3 and 3, right? That's 6. Is that bigger than 7? That's a no. 6 is not bigger than 7, right? Because this is my C, right? This is, in this case, this is A. We have to check to see if it's a triangle. This is B. And so I add them up and I get 6. Is that bigger than C? The answer is no. So C does not form a triangle. And if it can't form a triangle, then there's no need to find out if it's acute, right, or obtuse because it didn't form a triangle. Part D. Okay, so what are my smaller sides? It's going to be 3 and 4. So we always check first to see if it's a triangle. We check using this relationship right here. We add the two smaller numbers. 3 plus 4 is 7. Is that, we never change this direction, by the way. Is 7 bigger than, what's our C value? 7 bigger than 5. Yes. Okay, so now we do the work of using the Pythagorean theorem to find out what kind of triangle it is. So we set up C squared. And generally, by the way, we don't use this formula. This is the one we present to you in problem 1. We're just using the formula from problem 1 to help us decide what kind of a triangle it is. If we want to solve for the actual side, we'd use the formulas from problem 2. Okay, so let's plug in these numbers. C is 5, A is 3, B is 4, 25, 9, 16. 9 plus 16 is 25. Fascinating. They're the same on both sides. So if it's equal, then it makes it a right triangle. So part D, yes, it's a right triangle. E, okay, we have, these are the smaller ones. 3 plus 2 is 5. Is 5 bigger than the other side, which is, this is going to be my C, by the way. C is the bigger number. Is 3 plus 2 greater than 4? Yes. So this is a triangle. Well, let's find out what type it is, yeah? C squared, blank, A squared, B squared. C squared is 4 squared. A squared is 2 squared. B is 3 squared. 16, 4, 9. But what is 4 plus 9? 13. So we get this relationship again. That makes it obtuse. Okay. So yes, it's obtuse. Okay, a Pythagorean triple. It's 3 natural numbers. So what is a natural number? It's the numbers that you would count when you were a kid, when you're playing hide and seek. Okay. Hopefully you were a regular kid. So he didn't go like -2, 0, 1.3, 7 over 5. That's how I counted. Not you, hopefully. You counted 1, 2, 3, 4, 5. Okay. Those are natural numbers. So no decimals. All of them have to be positive, not 0. And they have to be whole numbers. Okay. So if I have 3 numbers, and if they satisfy the Pythagorean theorem, then it's a Pythagorean triple. Now, you might want to go back and look at your notes. Like if we look back at, for example, problem 3, all of these problems, they form the right triangle, and we use the Pythagorean theorem to solve for these sides. So all of these numbers satisfy the Pythagorean theorem, but not all of them are whole numbers, right? So for example, here there's decimals, decimals, and decimals. So this is not a Pythagorean triple. Oh, whole number, but do you remember what this one is? It was a decimal, not a triple. Whole number, decimal, not a triple. Okay, everything's got to be a whole number. Do you remember this one? Well, we didn't do this one. Let's go back. We did actually do this one, right? Because what was this? This was 3, this was 4, and this was 5. And 3 squared was 9, and 4 squared was 16, and this was 5 squared, which is 25. and then that being 25 equals 25. So this satisfies the Pythagorean theorem, and all three of these were whole numbers, so this is actually a Pythagorean triple. So in other words, if I have whole numbers and they check out with the Pythagorean theorem, then they're triples. The end. Okay? Now just because I give you any three whole numbers doesn't mean that they're Pythagorean triples. They have to actually work. They have to be equal. So for example, part A, right? We identify A, B, and C. C is going to be the bigger number, 5. 5 squared, 3 squared, 4 squared, 25, 9, 16. Is 25 equal to 25? Yes. So, guess what? A is a triple. These are triples. They're whole numbers, and they check out. Next one, part B. What's the bigger one? 4. That's my C. So let's check it out. 4 squared. Is that equal to 2 squared plus 3 squared? 16, 4, 9, 16, 13. Are these the same? No, not a triple. Next, C, 6, 8, 10. This is my bigger number. So that's my hypotenuse. 10 squared, 6 squared, 8 squared. 10 squared is 100. 6 squared is 36. 8 squared is 64. Add those up. I get 100. They're whole numbers and they're equal. That's a triple. Now, can I boggle your brain here for a second? How are A and C related? Well, look at C. C is 6, 8, 10. What if you halved all of these numbers? You would get 3, 4, 5. So spoiler alert, there are families of triples. So if you take a triple, if you know that a set of numbers is a triple, and you want to just multiply them by a number, then it makes that a triple as well. So for example, we know that 3, 4, 5 is a triple. If you double those, you get 6, 8, 10. That's also a triple. What if you tripled these? That would be 9, 12, 15. That's also a triple. So any multiple of a triple that you know is also a triple. Okay, let's do this last one, 17. So that's my hypotenuse. 17 squared. Let's do 8 squared and then 15 squared. 17 squared is 289. 8 squared is 64. 15 squared is 225. And if I add those two up, I get 289. So we have three whole numbers, and they happen to be equal. When I do the Pythagorean theorem, it checks out. So by me setting up the Pythagorean theorem and it being equal, that's what it means to satisfy the Pythagorean theorem. So to satisfy the Pythagorean theorem means I plug the numbers back into the right spots, and it actually checks out and is equal. So this is a triple. For your summary, if three numbers are given, what can you do to decide if they form a triangle? And if they do, what can you do to find out what kind of triangle it forms? Don't get stingy. Do the summary. Do some explaining. Use some words. You need words.